Hi everyone, welcome to our lesson 22. My name is Professor Edward. In today's lesson, we will practice rationalization of denominators, and simplifying the expression so produced. Okay, we will start off with an example. And that is, let's suppose we have root 1 over 2, and we are supposed to add it to root 1 over 8. From our previous lessons, we could really express this expression in another way. That is, since this 1 over 2 is under the root sign, we can kind of break it up and say root 1, which is the square root of 1, which will be 1, divided by root 2, root 2. Then we can add, again, root 1, which is square root of 1, which is 1, divided by root 8. Now, from there, we begin by looking at the denominators because we are trying to rationalize the denominators. What that means is trying to get the root sign from the denominator part of our fractions. And we'll do that effectively by multiplying each denominator by a value which will allow us to get rid of the root sign. And that for root 2, it will be root 2, because root 2 multiplied by root 2 will give us 4. But remember, what you do at the on one part of the fraction, you must do it exactly the same thing to the other part. So we need also to multiply the numerator by root 2. Now here, we look for a number related to 8, which when we multiply by it, we would get a perfect square. Now 8, we can't have a perfect square, so 1 can't do, but 2 can do. So we say let's multiply this by root 2, because root 2, or rather 2 multiplied by 8 will give us 16, which we can easily find a square root of. So this expression now will become root 2 divided by root 2 multiplied by root 2, which will give us 2 plus 1 divided by root 16. And root 16 will give us a 4. So then, from here, we will, oops, we forgot one thing here. Whatever you do to one part of fraction, you must do the other. So since we multiplied by root 2 here, we should also multiply by root 2 here. So this bottom expression then becomes root 2 over 2, as we've seen, and also the top here becomes root 2, square root of 2. So here we have root 2 over 2 plus root 2 over 4. And then we can try to do the ordinary arithmetic by adding the 2. The denominator here, the lowest common multiple will be 4. And 4 divided by 2 is 2 times root 2 will be 2 root 2 plus 4 divided by 4 is 1, and 1 times root 2 will be root 2. So finally, we will get the top becoming 3 root 2 divided by 4. Sorry. So we'll have, okay, sorry about that. It will become 3 root 2 divided by 4. Maybe I should write it here, sorry. So this will become 3 root 2 divided by 4. All right? Okay. Now let's try out another example. This time uh, with, with a subtraction. Let's suppose we are given a number like root 1 over 3, and we are told minus root 1 over 27. Again, as I said, we can break our fractions here into two parts. So we will have root 1 on top of this 1/3, which will give us 1. And then at the bottom, we'll have root 3. And in this case, we'll have again 1 and have root, sorry, we'll have root 27. So from here, we then try to rationalize the denominator by getting rid of the root signs at the bottom. And again, as I said, we multiply the denominator by another value, which will get rid of the root sign. And so this expression will become 1 divided by root 3, multiplied by root 3, the denominator, and what you do to one part of a fraction, you must do the other. We also multiply the top by root 3, minus, yep, we have root 27 here. So we can multiply out the denominator by root 27, because root 27 times root 27 will give us 27 when we multiply out. And the top will be root 27. So we can then move on to simplify this expression here. So the bottom will be root 3 times root 3, which will be 3. And the top would be 1 times root 3, which will be root 3 minus root 27 divided by 27. Now, once we get to this point, we can then try to see how we can simplify this fraction here. And we can do that by taking the lowest common multiple for between 3 and 27, which will be 27. So 27 divided by 3 will give us 9. So we have 9 root 3 minus 27 divided by 27 is 1 times root 27. We'll have root 27. So we need to simplify this expression further now. Now, we have two different roots, root 3 and then we have root 27. So we will first write out 9 root 3 minus, then try to change this root 27 into something similar, something simpler, but similar to root 3. And we can see that we have number 3, which can be multiplied out 3 times to give us 27. So since we are trying to find the square root of 27, if we can put it here, it's the same as saying root 3 times 3 times 3. 3 times 3 will come out as a solid figure on its own, 3, and then we'll remain with the root 3 still under the root sign. And all this is over 27. Now, from here, we can move on to simplify the coefficients, as it were. So when we divide by 3, that will be once. We divide by 3, that will leave us with 3. And then we divide by 3, this will leave us with 9. So, finally, we will have 3 multiplied by root 3 minus root 3 to leave us with only 2 root 3. And the denominator will be 9. So this will be our final answer. So now, if this lesson helped you, don't forget to like, share with anyone you think needs it, and subscribe for more algebra made simple. See you in the next lesson, and bye for now.